Hello everyone, welcome to my channel. In this video I have this very intriguing integral to evaluate, and it's the integral from -1 up to 1 of this expression dx. The question is, where do we start from? Well, looking at the plus sign there within the brackets and the x to the power 4, maybe distributing x to the power 4 first and then taking 3 out because it's a constant. That would be the starting point as follows. So we have the integral from -1 up to 1 of x squared sine power 5 of x plus 1. Allow me to use square brackets here. We have x power 4 all over 3 dx. So what I was saying is take 3 out because it's a constant. We have 1 over 3 times the integral from -1 up to 1. Distribute x power 4. X power 4 times x power 2. You agree with me? It will be x power 6 sine power 5 of x plus x power 4. And we are saying this times dx. Right, now from here we distribute the integral sign and dx, keeping 1/3 out as follows. So this is 1 over 3. Allow me to use square brackets now, and I'm saying the integral from -1 to 1 of x power 6 sine power 5 of x dx, and then I'm going to say plus this part here, the integral from -1 to 1 of x power 4 dx, and then we can close a bracket like that. Now I'm going to say that this is the same as 1 over 3. Distribute 1 over 3, that's what I'm trying to say, times the integral from -1 up to 1 of x power 6 sine power 5 of x dx plus 1 over 3 times the integral from -1 up to 1 of x power 4 dx, like so. Now moving to page 2, watch what I'm going to do now. I'm gonna split these integrals as follows. That will be equal to 1/3, let's say I1, plus 1/3 I2. So we have to evaluate I1 and I2 separately. You will agree with me that I1 is basically this integral here, and I2, it will be that integral there. Let's work out these integrals separately. So I1 is the integral from -1 up to 1 of x power 6 sine power 5 of x dx. Now this is very difficult. If you look at the expression in the integrand there, we have x power 6 sine power 5 of x, and then we have dx there. The problem is this part. What technique do we employ here? Well, first of all, let's determine what kind of function this one is. So we're going to say let f of x be equal to x power 6 sine power 5 of x. What are we trying to do here? Well, I want to check what kind of function is this. Is it an odd function or an even function? So we are now going to say, but what does this mean? This means x power 6 sine of x, the whole of this expression, power 5. You know that's what it means. So we're saying f of x equals that. Now I want to say, what do we get when we say f of minus x? F of minus x, you'll agree with me, we put minus x here, minus x there, and minus x there. We're going to get minus x to the power 6, and then open brackets, sine of minus x, close brackets, power 5. Now this, obviously, you'll agree with me, it's x power 6, and that part there, within brackets, it will be minus sine x. Remember, sine is an odd function, power 5. Now, so what do we do next? Well, this expression inside square brackets is the same as the following. Watch this, -1 times sine x. That's what it means, power 5. Now, using laws of exponents, we're going to raise minus 1 power 5 and sine x power 5 also. So this is the same as x power 6 times minus 1 power 5, and then we have sine minus sine x. Actually, I didn't need to put brackets there, but we have to put brackets like this, power 5 there. Now, minus 1 power 5, you know, is minus 1. Take it out. This is minus x power 6 sine. Now, I'm going to write this like this part here. Now, notice that this expression here, if you agree with me, is exactly this part here. Is exactly f of x. There it is, f of x equals that part. So we're going to remove that and replace it with f of x. And what do we obtain? We obtain the following. That part is just equal to minus f of x. This tells us that x power 6 sine power 5 of x is an odd function. Why is this important? This is important because of the following fact. See here we have integral from minus 1 to 1. This is an example of what we call a symmetrical integral. A symmetrical integral is symmetrical about 0. Remember, 0 is right in the middle of minus 1 and 1. And if this is an odd function, there is a fact, a mathematical fact, which says that if f of x is an odd function, what does it mean? It means, so I'm going to say IE here, f of minus x equals minus f of x. If this is true, then the integral from some real number minus a to some real number a of f of x dx is equal to 0. Remember, we're saying a is a real number. This is what it is for an odd function. So what are we saying? We're basically saying now that I1, therefore, we have established that I1 is an odd function, remember, from here all the way up to there. And therefore, we can conclude that this integral actually evaluates to 0. So therefore, from here we can say, therefore, I1, which is the integral from minus 1 to 1 of x power 6 sine power 5 of x dx is actually equal to 0. Now let's go back to page 2 there. It means we put 0 here, this whole expression collapses. We just have the second integral to evaluate, and then we're at the answer. So we proceed as follows. We evaluate integral number 2 now. Where is our second integral? Our second integral is this one here. If you can see, is that part. So I2 is the integral from minus 1 up to 1 of x power 4 dx, which is very easy to integrate because we're simply using power rule. So this is x power 5, remember 4 plus 1, and then we have to say 4 plus 1 as well. But it's evaluated from minus 1 up to 1. So this is x power 5 over 5 evaluated from minus 1 up to 1. Allow me to take 1 over 5 out, and then we're going to say, watch this, x power 5 evaluated from minus 1 up to 1, like that. So this is 1 over 5, and then what do we have there? It's going to be 1 power 5 minus 1 power 5. Now this is 1 over 5, and what are we saying? We're saying 1 minus 1, obviously, and that is 1 over 5. If you agree with me, this is just 1 plus 1, and the answer is 2 over 5. That's integral number 2. So we just have to go back here, and evaluate, complete our integral, taking us to page 5. So we're simply saying, therefore, the integral from -1 up to 1 of x power 2 sine or 5x plus 1, this times x power 4 all over 3 dx, which simplified to 1 over 3 times the integral from -1 up to 1 of x power 6 sine or 5 of x dx plus 1 over 3 integral of x power 4 dx, that's from -1 up to 1, simply gives us 1 over 3 times 0. We saw that this actually is 0, and then plus 1 over 3 times, we saw that that's 2 over 5. So where is it? Well, here it is. There is your 2 over 5 on page 4. There is 2 over 5. That integral evaluates 2 over 5. So we put 2 over 5 in our space here, 2 over 5, and what do we get? We get 0 plus 2 over 15, and the final answer is 2 over 15. That's our final solution to this integral. Now notice that we had a trick here, and the trick was to see that this is a symmetrical integral. Remember symmetrical integrals from -2 to 2, from minus pi by 2 to pi by 2, from minus pi to pi, from minus 10 to 10. Whenever you have that, you need to examine the integrand, whether it's an odd function or an even function, or it's a combination of an odd and even function, like in our case here. Remember, removing the brackets, we could see that we are ending up with an odd function here and an even function there, right? So we could also have evaluated this by saying the integral 2 times the integral from 0 up to 1 of this expression. You would still find the same answer as 2 over 5. Please check that out. All right, I'm going to stop here in this video. See you in the next one.